I'm Nigel Mbaye, Customer Success Manager here at KETIV Technology and your AVA host for all days.
All days, yeah.
All days. So we're here in Southern California. It's not so sunny today, but it is fine. We're going to be having a great session today here with Alex Alvarez. So Alex is one of the engineers here on our team who works primarily on post-sales projects. So Alex, you've been working on a couple of automation projects.
Absolutely.
You do a lot of the training for Inventor and some of the manufacturing workflows as well.
Yeah.
Things like nesting, CAM, et cetera, right? So I think from our team, Alex is probably the best person to go ahead and talk about some of this, as it kind of blends two things that Alex has been working on over the past couple of years. And it just makes sense to have Alex here on this webcast. Also, Alex is a couple seats away from me, so I've been watching him put this all together. It looks really awesome. I'm really excited to see what the final product is. With that, I think we're going to go ahead and get started. I think if anyone has any questions, go ahead and type those into the panels at any time, and we'll go ahead and answer those.
Yeah, absolutely. Thanks for that, Nigel. Yeah, so a little bit of background of why we're even doing this webinar, right? We've been having a couple calls. I actually got on a call with a customer not too long ago, and we went really through the same exact issues. So people are really starting to get the idea of automation. They're really starting to embrace it. And with that comes manufacturing, right? So you still have to make the parts that you're automating. And we're trying to really figure out the best way or the best method to go about that. So as always, just some key purposes or key reasons why we want to do these webinars. Highlight the importance of design automation. So like I mentioned a few years ago, maybe that wasn't really on everyone's top list or on everyone's area to hit. Now as maybe project times are getting a little bit shorter, you're expecting a little bit more out of your engineers. You want to make sure that you start expediting or really increasing the efficiency of designing your products. And with that, you have a lot of redundant tasks, right? So whether you're doing, your basic modeling, or maybe you're just programming your part, there's always a lot of redundancy in those tasks. And you'll see that in some of the methods or some of the workflows that I showed today. How do we eliminate that? How do we cut some of those tasks out? Let the software, our CAM software work for us and do some of the heavy lifting there. So two really key important, topics that we're going to touch on today are going to be iLogic. So iLogic is going to be one of the biggest driving factors that's going to automate our designs. And again, with iLogic, what can you gain from that? You can reuse and iterate, really infinite amount of product variations. It depends on how you set up user parameters, how you set up the rules that are going to be driving these parts. But ultimately, you can just cycle through many parts without having to restart from scratch or really having have your engineer start from just a base model, right? So again, reuse most of the geometry that you have already. Something that I read online not too long ago, it was where we have a lot of engineers who've really been in the company and they know all these rules that are driving these parts. But again, that's knowledge that they have or that they've acquired throughout the years. Now that you have, most of these young engineers, they're not really too sure of how the product is behaving or how a configuration from part A to part B is gonna behave. Capture that inside of iLogic or using iLogic and use the rules to drive, those two different configurations. And of course, increase design consistency. So we're all humans, we all make mistakes. Instead of entering 0.01, you can enter 0.1, and then that'll give you drastic changes, right? So again, have the computer work for us, and then know for a fact that your designs are going to be, up to spec. The next topic, or the most important topic really in this one as well, is going to be Inventor HSM. So that's what we're going to be using to drive some of the toolpaths, which is consequently going to drive our machines. Again, the back end behind HSM is it takes the toolpaths that you programmed on your part, creates that into readable language, if you will, that your machine is going to be able to read. And then, of course, that's what's going to drive or move your machine. So in Inventor HSM, what we're going to be talking about is how to increase programming efficiency. So we're going to take a look at the part that we're programming today. Fairly basic. It's not too complex. But again, it's going to highlight some really key important design aspects that I feel like you can take away from how you're going to be programming the part. What I mean by that is you're not going to be limited to just using one toolpath or 2D toolpaths in this case for this part. Try to think a little bit outside the box and then expand on some of the 3D toolpaths or some of the other toolpaths that Inventor HSM has to offer. And of course, like I was saying, let the CAM software do the heavy lifting for you. So if you don't have to really reprogram, a part from scratch or start your setup from the very beginning, just let the CAM software do the heavy lifting for you. Let it regenerate the toolpaths based off of the model geometry, and don't worry about really programming any of these parts. Along the way, of course, like Nigel mentioned, ask questions. If there's something that you missed, feel free to ask away, and we'll do our best to kind of touch on that question. But with that, let's go ahead and jump into the software. Kind of dive right into it. So of course, this part was created using Inventor. We have our 3D model tab. Maybe a lot of you guys are familiar with the 3D model, sketch, inspect. If this is your first time using HSM, or you're just trying to really get into the the nitty gritty, I guess, of the software. Once you install Inventor HSM, you do have this CAM tab. So again, it's built right into the software that you use to model some of these parts. So everything is really going to be familiar to everyone. So your designer is going to know exactly where he's at. Maybe your machinist or your manufacturing engineer, he's going to know exactly what was used to create the part. And then that way you guys are both kind of in sync when it comes to programming and designing this part. A quick little rundown. The workflow that we're going to take here is extremely straightforward, going from left to right, kind of like reading a book. So starting off with your setup, adding a few toolpaths, whether you're using 2D toolpaths, 3D toolpaths over here, fourth or fifth axis machining, you also have that available to you. And even lathe, right? So turning toolpaths as well, 2D profiles. So if you have a laser, water jet, or a plasma cutter, you can program those machines using Inventor HSM. And really the last step, or the final, I guess, the goal line here is going to be posting out to your machine. But prior to that, you do want to make sure that you simulate your entire toolpaths, right? Your entire setup. You want to make sure that you have the correct toolpaths and you're not maybe gouging the part, you're going a little bit deeper than you expected. Simulate the part. There's some pretty handy tools in there that really show you if there's some sort of an error. We do have part comparison as well. So if you want to compare maybe the stock to the actual part itself, it will tell you, or it will show you where you have material left, or maybe you cut a little bit too deep. So pretty handy tools there. So let's go ahead and jump into the setup here. Again, pretty straightforward. I'm not going to spend too much time kind of talking about the setup. We do have a few videos that are kind of geared more towards that. But in here, again, really just create a milling operation. We're going to be using a mill to machine this part. And what we want to do next is set up our stock. So there's a couple ways to do that, right? So I do want to go into the second tab here, select the part, and we don't want a from solid, right? We want some sort of a relative size cylinder in this case. And once you select a circular reference to the part, it automatically gives us the correct preview there. In this case, I do want maybe some sort of a small offset, just enough so I can machine on the outside here, and maybe something that we can hold on to at the bottom of the part. So maybe 0.2. What's neat about this too is that I know that my material my material supplier sells material in maybe 1/8 inch increments, right? So I want to round up whatever values I have here to the nearest 1/8, right? And then at the very bottom, it tells us exactly what size stock I'll need in order to to satisfy these parameters. All right, so everything's looking good here. Really, what I need to fix though is going to be this little triad here, right? A lot of people do get confused, so they see this triad and they think, okay, maybe I have to reorient my part so that it matches exactly how it's going to sit on the machine. I mean, that's nice. It's always it's always best practice to have your model WCS or your work harness system here match exactly how it's going to be manufactured. But for the most part, I mean, sometimes you receive a part from from a different customer. Maybe you guys are modeling using two different techniques. It's not always going to be the case. So what you want to really pay attention to is going to be the WCS inside of the CAM workspace, right? So I can't tell you guys how many times I've kind of covered this with the customer. They're trying to match the part to this. But really, the WCS inside of the CAM workspace is the one that's gonna matter to you guys, right? So in this case, you want to go ahead and change your orientation over here on the first tab. One key thing here, though, so I am going to be changing the attachments here. So again, this base is going to be some sort of a base that attaches to a part, and it's going to control how many attachments are going to go into it, right? So we have a 2, 3, and a 4 attachment base. In this case, I'm working with a 3 attachment. So when I switch to 2, I mean, if I select this face, for the WCS, it's going to reorient the Z-axis as expected, right? But you want to be careful because sometimes when you change configurations and you kind of lose this face for a little bit, the setup is going to run into issues, right? So instead of choosing that face, and what's neat about this is that you can now go into the model tab, right? Before you had to kind of escape the CAM tab and kind of, start from scratch here. Now what you can do, go to the model tab, expand the origins, and we want our Z-axis to be in line with the Y-axis here, right? So let's go ahead and select that. It automatically reorients that for us. The X-axis, I'm not too worried about. It's fine in that orientation. If I did need to reorient that, again, do that using the same method of selecting the origin axis there. In this case, let's go back to the CAM tab. And now the last step here is going to be selecting some sort of a stock point, right? Where do we want that home position to be at? In this case, we want that to be the center of the cylinder, and hit OK, right? So pretty straightforward, not too bad. Reason why I went to a relative size cylinder is because this part, or this specific part, has the option to change in diameter. And I will talk about that. That's going to be a little bit down the line of how I created this form and some of the logic that's behind this specific model. But for now, let's go ahead and continue kind of adding some toolpaths to this part. Next step is going to be adding a face toolpath. So again, we just want a nice flat surface over here on the top. Again, if you're brand new to Inventor HSM, so notice that we have this dialog box. This workflow that you see here, so we have the tool tab, geometry, the heights, passes, linking. Those 5 tabs you're going to see in the 2D toolpaths, the 3D toolpaths, 4th and 5th axis toolpaths, right? Even the turning toolpaths. So what that means for you is that you're always going to know exactly where each option or where each command is going to be at. Maybe you want to change how aggressive the step over is on the toolpath. You're going to know for a fact that that's always going to be in the passes tab. Right? Maybe you're cutting a little bit too deep. You want to limit the height of the toolpath or the tool. That's always going to be in the heights tab, right? So on and so forth. So this never changes. Maybe for the turning toolpaths, the heights is labeled a little bit different, so it's radii. But again, that makes sense, right? Because we're going to be controlling how deep we're going to go into the radius of the part. So here with the face toolpath, really all I have to do is just select the tool. In this case, it's a 2-inch face mill. Select that and click OK. So the software is smart enough to know where the top of the model is at, and it creates a toolpath automatically to match the top of that model. So we can control that. If we maybe, if that was a little bit too much of an aggressive cut, we can do that in multiple step downs. For me, I just left about 20, 30 thousandths on the top of the face, so it's going to be fine. Yeah. All right, so the next step here, maybe we want to drill or do some sort of a boring operation here. Yeah, so let's go ahead and do a drilling operation just so we can remove most of the material from these holes here. So again, drilling operation, selecting the tool, 3 coordinates drill, and then select the hole faces, right? We want to select the same diameter. What's nice about this drilling operation is that it shows us exactly how deep that tool is going to be going, and it gives us a nice little preview of the tool path itself as well. In this case, I do want to drill the drill bit through the bottom of the part, so let's go ahead and just enable this little checkbox, and then give it a small offset here. All right, not too bad. Nice thing about this too is that you can reorganize some of these toolpaths. So maybe you want the drill toolpath to be on the very top, just drag and drop, and now you get to reorganize some of these toolpaths. All right, so next step, probably a roughing operation on the outside. So again, maybe 2D adaptive, right? So one of the money makers, if you will, inside of HSM. Let's go ahead and select our tool, and then select some sort of a pocket, right? So keep track of what I'm doing here, right? So I'm selecting the tool, I'm selecting geometry here, or I'm selecting chains. Keep in mind of what that's going to happen, or what that does when you change, or you change configurations, or maybe you remove this triangular feature, right? In this case, I can go ahead and click OK. Face, and then the 2D adaptive toolpath here, and then now let's go ahead and add some sort of a finishing operation, and then maybe like a pencil toolpath or something to clear that fillet. So again, you can start seeing how repetitive some of these tasks get, right? So imagine if we had maybe same exact part, just a different configuration. Maybe it was a little bit bigger. You can start seeing how some of these tasks are pretty redundant, right? So select the toolpath, select the tool, and then select some of your geometry, right? So everything's looking good here. Finally, let's go ahead and select some sort of a pencil toolpath, and then select that 1/4 inch ball, right? So again, we do have a kind of video on 3D toolpaths. So if I'm not really explaining some of these toolpaths all that much, there is a video that we've created that explains, goes into detail with all these different toolpaths. But anyways, yeah, so we have the drill, the face, 2D adaptive, 2D contour, and then the pencil toolpath, right? So if we simulate this, again, that's going to be really the step prior to posting. Go ahead and hit play, and then it shows you exactly what these tools are going to be doing, right? You can speed up the simulation a little bit. You can change material over here on the left, show transparency. Maybe you want to be cautious of the collisions here, so you can turn on the stop on collision. And as I mentioned before, the show part comparison is also a pretty handy feature. Right, so we can skip through some of these. There we go. All right, so not too bad, right? Maybe we can add some sort of a of a boring toolpath here. So we can go ahead and select bore, and again, just using that same 1/2 inch flat end mill, selecting this hole here. Now, what's nice about the board toolpath too is that it works similar to the drill toolpath, right? So it automatically selects the same diameter holes. And here I probably want to maximize the step down a little bit here as well. So if we change, we want to make sure that we go to lead to center, and then we want to change the pitch of this a little bit. 0.1. Notice that you can start seeing it expand a little bit, right? So depends on how aggressive you want to go on this cut. You can just start changing that, and it kind of spirals its way down into the boards there. Hit OK, and then of course you can change that to be the top. All right, so everything looks good here, right? Let's go back to the 3D model. So again, now we're working with the model itself, and let's take a look at some of the configurations, or some of the configurations I use for this part. First thing that you want to do when it comes to modeling or trying to automate your design is figuring out which parameters are going to be changing. So in this specific model, we have the diameter of the hub is going to be able to change. Maybe the thickness here is also going to change. Of course, the bore diameters, wall thickness, which I have set to be this, and then finally the attachments, right? So that's going to be the biggest option here, the biggest parameter that's going to change or make the biggest difference inside of this model. So what I mean by that is we can go over here, change that to be 4 attachments, and it automatically changed to the 4 attachments. right? Go back, change that to 2, changes to 2 attachments, and so on and so forth, right? So I can kind of play around with this a little bit and maybe add you know, 5 attachments depending on what the customer was expecting. But yeah, so notice how quickly we can go back and forth between some of these different, you know, some of these different configurations. So if we take a look at the rule, really the rule was just a suppress and unsuppress feature rule. So if we go to edit rule, one of my favorite really iLogic rules is the case, right? So we're selecting the case attachments. We have cases for the different configurations. And like I mentioned, all we're really doing is suppressing and unsuppressing certain features. If you guys do want access to this part, feel free to email me. I'd be more than happy to share this part so you guys can take a look at, you know, some of the steps that I took. But yeah, I mean, that's how easy it is. You really don't need any programming or much programming background in order to create some of these automations. So, you know, I guess a lot of people have this misconception that in order to automate this specific design, you need, you know, years of programming knowledge. You really don't, right? So it definitely helps. Don't get me wrong, it definitely helps, but you don't really need, you know, that high level of knowledge in order to do some of these simple automation designs. But yeah, we have, you know, we had a 3 attachment model. We switched over to the 4 attachment. So what does that do to my CAM workspace, or what does that do to my model? Well, let's go ahead and take a look at it, right? So we have the tool paths here kind of showing, hey, there's been a change to the model. Go ahead and regenerate your tool paths. Let's go ahead and do that. So right off the bat, we can see that the drill tool path isn't really working. 2D adaptive, you know, didn't generate, and you know, the board tool path here didn't generate as well. So a few options. What we can do is let me go back into the 3 attachment. So by the way, notice how I had to go over here to the user parameter and change, you know, in between attachments. That's fine, but if all your manufacturing engineer knows is, you know, the CAM workspace, and he really doesn't want to go into the user parameters, or maybe you have hundreds of parameters in here, and you know, you kind of want to limit, you know, how many parameters he sees, create a form for this specific model. So what I have here is a form that's going to drive, you know, the part. If we expand the form or click on the form, we get something that looks like this, right? So it's a nice little picture telling you, okay, what is this hub diameter parameter going to control, right? So it's going to control the outside of the hub. This is going to be the thickness, wall thickness, and then the board diameter, right? So it takes a little bit of time, but again, it makes sure, you know, it allows for you to get the point across to your other engineers or maybe your machinists, and shows them exactly what's going to be changing for this specific model, right? So in this case, maybe you want to change to 5. Hub thickness, maybe, you know, 5/8 or something like that. Change that to 1 1/8. Hit apply, and then you can see that there's like a slight little change there, right? So when I do that, if I go back into the 3 attachment, hit apply, and that's the thing, right? So it's real-time changes that you don't have to necessarily reload or restart the software in any way. It just automatically changes for you. So here's the thing, right? So if I go back to the 3D adaptive, it works, right? So it regenerates the toolpath. So with that said, well, maybe what we can do is duplicate the same setup and then just call this one for attachment, right? So if we do that, let's go to the base configuration. Let's switch the attachments back to 4. Try to regenerate that. So now the drill operation, we can go back and edit that. And we can say, okay, well, the whole faces are going to be these. And then the 2D adaptive is going to be from this pocket outward. Oops. Clear this out. So notice every time I'm editing some of these toolpaths, it gives you a warning, right? So it's telling you, hey, it's missing references. So that right away is telling you that there's, you know, some sort of feature that's missing. In this case, circular reference is going to be that hole. And there we go. So we have the 4 attachments setup essentially created. So now what we can do is switch between 3 and 4. And regenerate this. So there's your 3 attachment setup. Here's your 4 attachment setup. And that's fine, right? That works. The reason why that works in this case is because we only have 3 configurations. So that's not bad at all. It's not too hard to create duplicates. But what happens when you start getting into the 30, 40, 50 different configurations? Are you really going to want to create that many setups for a single part? So that's where you want to start taking a look into 3D toolpaths. So I'm not going to get into kind of the whole background behind 2D and 3D, but really the gist behind 3D toolpaths is that it's driven specifically off of model geometry, right? So if you're driving a toolpath from model geometry, that means that this model can change between 2, 3, 4 different attachments, and it's not going to care, right? As long as the geometry is there and it's a fine geometry, then it's going to be able to generate some sort of toolpath. Where you do start running into issues is when you start selecting some sort of a chain, right? So you do want to be cautious of either selecting like a containment boundary, some sort of a chain that is going to change down the line, because again, as you can see with the 2D toolpaths, it's not going to update correctly, right? Because it's always going to have that missing reference. So that's really the biggest difference between the 2D and the 3D toolpaths, is that 2D toolpaths are really strictly driven from 2D geometry, right? A chain, some sort of a loop. It's always going to be driven from that, whereas a 3D toolpath is driven off of model geometry. So with that said, let's go over here, duplicate that toolpath, and rename this one to be 3D toolpaths. Okay, so looking at this one, just so we can reference which one's good and which one's bad. So we can tell that the drill operation is no good. So we can go ahead and delete this one. We know that 2D adaptive is no good either, so delete that one. 4, no good, delete. All right, so now what we're left with really is a face, a 2D contour. And now this 2D contour is fine, right? So you can mix and match 2D and 3D toolpaths. In this case, I can leave the 2D contour because I'm always going to have this circular edge on the outside. I know for a fact that it's not going to change. If it was changing, or maybe it was changing between a round cylindrical surface to a rectangular surface, then that's when you might have to get a little creative. In this case, 2D contour works for me, so I'm going to leave it there. So now let's go back to the drilling operation, right? So again, going back to the cam tab. One thing you do want to make sure you do first, though, is set this to be your default folder. There we go. All right, so let's go ahead and do a drilling operation here. And we're going to be using the same tool, so we want to use that same 3/4 inch drill. Now let's go to the geometry so we can tell the software exactly what we want to machine. In this case, right, so we have selected faces, we have hole faces, select same diameter. So I really don't see anything in here that stands out. If I hit the drop down though, I have this diameter range, right? So this is really huge, especially if you're going to start automating some of these designs. Now I like to think that Autodesk allowed for this option with kind of with automation in mind. I'm not too sure if that's the case. I mean, I like to think that is the case though. So in this case, let's say that the minimum diameter hole is going to be 0.7. I know that the maximum size hole is always going to be 1.5, and really, whatever, I can change the bore size to be 1.25, 1.3. It doesn't matter. It's always going to want to machine or try to create a drilling toolpath for those 3 holes. Now that brings up the question, well, what if I have holes on the outside and and I don't want to machine those? Well, you do have a containment boundary option in here as well. So again, in this case, maybe I wanted to contain the toolpaths to be, on the inside of this. I can select that to be a containment boundary. Maybe, there's a it's a bigger part and it has, it's a fixture plate and it has holes on the outside and I don't want to machine those. well, that's when you might want to get into containing it or containing this toolpath with the sketch, right? So you have multiple different options. What you don't want to do though is contain the sketch with a loop that's going to change, right? So again, programming these parts are going to take a little bit more thinking, a little bit more thinking outside the box. But down the line, it's going to save you guys a lot of time, right? So it's better to do this right the first time and save some time down the line and not have to reprogram the different configurations. In this case, though, I only have 2, 3, or 4 holes. They're always going to be in the range of 0.7 to 1.5. I do want to go ahead and set the height here once again to be through the bottom of the part, 0.1, and then click OK. I can bring this to the top. So we have the drill, we have the face. Now let's go ahead and add the roughing strategy. Right, so again, 3D adaptive. So similar to the 2D adaptive where it's going to create a similar looking toolpath, but it's going to look at the entire model that we have here. So selecting that same tool. There we go. And then with 3D toolpaths, really the biggest thing is going to be containing the toolpath. So if you guys have used 3D toolpaths, you'll know that they can be a little bit more complicated to use, right? They'll try to go into places you don't want the toolpath to go, and they can be a little bit of a headache if you're not too familiar with them. The 2 biggest ways to contain toolpaths is going to be with geometry, some sort of boundary, or by heights. So in this case, if I didn't contain the height, it would try to machine past this fillet, maybe try to machine the entire part here. So I do want to limit that to be up to the face. Now, you might be asking yourself, well, why are you limiting, to the face? What if that changes? Well, if it changes in height, that's fine. The software is always going to be smart enough to pick up the change in height. It's just not going to be able to pick up a change in, in loop selection, or, if it's missing that specific loop. But a change in height for a face, that's completely fine. In this case, really the top height might be from the model top, right? And then that's going to be fine there. So it does take a little bit longer to generate, but nonetheless, we do get a pretty decent looking toolpath. The only issue that I see with this one is that it's trying to machine these holes here, right? I mean, that might be fine. That might be what we want in this case. For me, that's not what I want. A couple ways to kind of go around this. So what we can do is create some sort of a patch boundary. Essentially, create a patch, like a 0 thickness surface that's going to cover these holes, and use those surfaces to kind of bypass the toolpath going in there. Now that's fine if it was a single part, but keep in mind that this part is going to change configurations, right? So that either means that we have to machine or create patches for the 2, 3, and 4 configuration, or we create some sort of surface over on the top. Either way you look at it, it's going to be kind of complicated, right? So instead, let's go into the 3D toolpath. And in the passes tab, we have this machine cavities option. Let's go ahead and turn that off. Click OK, and it bypassed, or it overlooked those holes that I had there, right? Again, I can clean this toolpath up a little bit. I can control the the lift height, maybe how long it stays on the floor of the part. I can do a lot with it, but for now, that works for me. Let's go ahead and move this toolpath up a little bit. So we have the drill, we have the face, 3D adaptive, and now what we want is some sort of toolpath over here that machines the inside of the boards here, right? So let's go back to our 3D toolpaths. For this one, there's a few options. For me, really, I found out that the 3D contour would probably work best. And again, using that same half inch flat end mill. So let's go ahead and select that. We probably want to turn on rest machining. So why do we want to turn on rest machining? Because otherwise it would try to machine, the outside of this surface here. In this case, you can give it a boundary though. So if you go ahead and select the outside of that boundary, right? We want to stay inside of that boundary essentially. Click OK. So again, I selected that boundary because once again, I knew that it wasn't going to change. So, this is always going to stay cylindrical. I'm fine with that. It's never going to change. So let's go ahead and fix this toolpath a little bit. So it's actually a good looking toolpath, right? Not bad, but it can take larger step downs. So let's go ahead and control that by going to the passes. Maximum step down, let's say it's going to be 0.75. That was probably a little bit too much. So we can go down a little bit. Right, but that's the thing. We can change, we can change some of these values, and we can get, kind of like real-time toolpath visualization, right? So we don't have to wait all that long in order for these toolpaths to generate. They automatically generate right after you make a small change to them, right? So there's a drill, there's a face, 3D adaptive. Maybe we want this pencil toolpath to be, a little bit higher, and we have that 2D contour on the outside. Maybe I want to finish, I want that to be the very last toolpath, so I can change that to be the last one there. And then let me go ahead and change that to be, okay. Let me generate this one. So now let's go ahead and simulate this, right? So we simulate this part real quick. So there's the drill, there's the facing operation. Now we're going to be roughing. There's a bore, there's a finish on the outside, right? One thing I can do too, so it does, kind of plunge a little bit here. So we do have that roughing operation, but it doesn't necessarily clean up the floor of that part. What I can do there is I can do a horizontal toolpath, and then essentially the horizontal toolpath looks at all the flat surfaces that you have inside of the model, and it creates a finishing pass around that, right? So if we right-click on this 2D adaptive, go ahead and do a derived operation, and then we want a horizontal. And we want the top height to be the model top, but we want it to be a little bit lower. So reason being is that we don't want it to machine the very top of this, the very top of that surface there. So once you hit OK, it creates, that finishing pass on the floor of the part. Right? So if we drag it up once again, we have the drill, the face, 3D adaptive. Now finishing pass on the floor of the part. We come back, finish the pencil toolpath there, and then the 2D contour. I'm not really liking this. Pretty sure the step down might be a little bit too big. There we go. Okay, that's better. All right, so really the real test here is going to be, well, are these going to update if I change, some of the model parameters? Well, let's go ahead and test it out. So we go to base configuration. Let's start off small here. So let's start off with, maybe 5.5. Hub thickness, 0.75. Pore diameter, 1.25. Wall thickness, 1.35. Hit apply. So that changes that. 3D toolpaths, Control G. So that's fine, right? So that we knew that was going to work. Really, the 2D toolpaths would even update if I just changed, geometry here that was either going to increase or decrease a little bit. The real test is going to be if it changes or if it updates when we change the attachments, right? So let's go over here to 4. Hit apply. 3D toolpaths, Control G. So now right off the bat, we can see some good signs. So the drill is automatically generating. Face, we knew it was going to generate. 3D adaptive generates. Horizontal is generating fine. Pencil is generating fine. Contour looks good. And then the 2D contour on the outside. Right, so that's huge, right? So we just eliminated essentially the need for a second setup, and now we did everything really in one setup here. Let's go ahead and change that to be a 2 configuration attachment. Regenerate this. Looks good here. 3D adaptive is still generating, but that looks good. Horizontal, pencil, contour, 2D contour. Right. Yeah. So that was, I mean, you know, like I said, it takes a little bit more thinking ahead or thinking outside of the box. But as long as you don't select any chains that are going to be changing or being suppressed, for the majority of the time, you're going to be golden for design automation, right? So that's what I had for this part. Again, hopefully I shine the light on what design automation looks like and how that looks like when you transfer that over to your CAM software. And again, that's huge, right? Having the benefit of a CAM embedded tool is that you can make a change to the model and it's automatically going to be able to regenerate your tool paths and your entire setup for you. Right. So again, if you have any questions, this is probably a good time to ask some of them. While you go back.
Yeah, well, before we get to questions, Alex, I'll let people type those in. Let's go ahead and make those couple of announcements before all that stuff. So I think this is like super, super importante. Yep. Every year we do What's New AVA sessions, and we've done this with product managers over at Autodesk for Inventor, Vault, and AutoCAD. And so, well, that's not changing this year. Definitely doing it again. So starting next week, we're going to be starting that webinar series again for What's New in Inventor, Vault, and AutoCAD over the next 3 weeks or so. AutoCAD's looking like it's going to be the week right after. I just have to confirm 100% for that. So make sure you attend those AVAs. It's probably some of my favorite AVAs over the course of the year. There's a lot of new stuff in Inventor that I've seen over in some of the Autodesk blog posts that I'm really excited to see, actual usage of the tools. Note that you probably, if you do have current subscriptions or you are on current maintenance, you should be getting access to all of these tools in your account portal. Maybe you've seen them last week, coming into this week. For those of you who do have things like collections and stuff, you might have to wait a couple more weeks for those things to show up, but they are coming. So Alex, if you just want to click that link real quick. Yep. Everyone who's signed up for a regular AVA will get invitations for this. So if you're watching this on the regular AVA channels, you should be able to receive invitations for this automatically in your inboxes as well. So if you need to send this to anybody, let us know. We'll go ahead and forward this over. Alex, if you just want to copy and paste that into the chat, that works too. And make sure you select all attendees as the recipients of the message. Go ahead and do that here. Yep, right there. Perfect. All right. So I'm really excited for those sessions. Hopefully everyone else is as well. It's probably, like I said, some of my favorite sessions of the whole year. And some of my favorite product managers from Autodesk are going to be giving those demonstrations to us. So I'm really excited for that. With that, let's go ahead and jump into questions and take a look at what we've got. Let's see. Adam here asks if there's a list online that shows all of the different iLogic functions. So there are a couple of good resources to look at some of the iLogic stuff. The first one being like the help documentation. Yeah, absolutely. Yeah, if you hit the question mark here, go to learn more or even help. You have this programming API help. That takes you to like a list of just everything that iLogic has and just the API programming help that Autodesk has created and developed for all of the users. So yeah, that's actually a good resource to know and to have under your sleeve. That's a good option. I know that's helped me along the way plenty of times. Yep. And that help bar that's right next to that, Alex, if you like all the way at the top that you can type into, is something that I see underused a lot by a ton of people that I talk to on a regular basis that have just a random question. If someone in the office walks by, it's like, how do you do this? Yeah. It's like, have you tried typing it into the help chat or the help chat, but the help bar in Inventor? And like, for example, Alex, if you go ahead into help and you write type sweep up there. Go Go ahead and do that for me real quick here. If you're wondering, how to create sweeps, or you have issues with sweeps, so on and so forth, this gathers all of the information from the Autodesk Knowledge Network, as well as gives you some information about some of the commands in Inventor. Obviously, if you highlight the command in Inventor, you just hover over it. Some of these will pop up as well. But yeah, there's a ton of stuff here. It uses the entire Knowledge Network database to get some of this information. So if you have questions on how a particular functionality works, what's going on, how to do A, B, or C, go ahead and type it into there. And there's a lot of great information there about troubleshooting, some of the documentation from Autodesk, so on and so forth. So cool.
Looks like I have a typo in the part. So I was working on this kind of late last night. But, so yeah, that's
okay, Alex.
Sorry about
a slight bout of dyslexia. I think Alex can't spell. Yeah, he can't spell attachment. Also, Alex doesn't type normally. If you've ever seen him. So, and Eric asks, if we're already signed up for the virtual academies, then are we going to get an invite for the What's New? Yeah, you're going to get an invite for that. Anything that happens on Thursdays at 10 a.m., you're automatically going to get invites for. And so whether that's, a session with Alex or a session from Autodesk, it's the 10 a.m. sessions that you guys are already signed up for. We do host a ton of other webinars, special webinars for things like Jumpstart training, productivity training, so on and so forth. Those are separate. So if that's something you need access to, or you have access to it, but you're not receiving invitations, call us and we'll make sure you get signed up for that. Alex, do you want to jump into Inventor real quick and show how you generated that form? Do you have the rule for that?
Yeah, this one right here.
Yep.
So we have a rule that drives the attachments, right? So that's going to be the first step. The next step is going to be just creating your form. Similar to the rule, you just want to right click, add a form, and it takes you into this little dialog box. Looks a little bit more frightening than it actually is. Nice thing about this is that it gives you, again, real-time feedback on how the form is going to look. So over here on the the right-hand side, you have all the exactly how that form looks to the users. But yeah, there's tons of info. If you need help with the form, you feel free to call us, and we have actual iLogic specialists who work with just iLogic itself and programming. So yeah, if that's something that you're interested in, feel free to reach out to us.
Yep, you just drag parameters over pretty much, and they show up, and you can edit them as needed, so on and so forth. So you can add drop downs for the selections. You can have it be a hard number that you type in yourself.
Mm-hmm. Yeah, you can have it be a slider if you want to make it easier for the users.
Yep. You can have it only work as whole numbers, so on and so forth. So it's really cool. It's super powerful. So like Alex mentioned here at the onset of this webinar, I think the most important thing to take away from any automation that you want to be doing is to utilize parameters in Inventor. Mm-hmm. And I think that's the biggest change for a lot of people who come from things like AutoCAD and stuff, is to leverage the parameters in Inventor. So when you are creating some of these sketches, and Alex, do you want to go to one of the sketches here that you made? And this is probably the last thing we'll cover before we go. Let's see. One of those sketches where you define some of that information. Yeah, so if you look at some of these dimensions that Alex has, they say fx and then colon and then whatever the number is, right? It's a function of some sort of number. And he's using parameters to do this. So it's really important that he names all of these so that when he goes to program later, he's not using D0, D1, D2,
Yeah,
I'm sure you've seen those parameters in your Inventor models. You got like D35. It's like, how do I know what my hole diameter is? And I think it's D17. It's like, well, it makes it easier if you just, when you're making these sketches in the first place, denote those dimensions as whatever the parameter is in text equals, and then whatever number you want or whatever equation you want to use.
Yeah, even if you're not going to be doing design automation, I mean, that's just good practice. Maybe down the line you guys do decide to do some sort of automation with that part. I mean, it's already going to be set up for you guys and ready to go, right? So yeah, it takes a little bit longer to maybe do the parameters, but I mean, down the line you're just going to be helping yourselves out, at the very end.
Yep. And that's like the one thing I just want to take away. So I just want to recap. So Alex, you showed us some cool little iLogic things. We have a ton of iLogic content. If that's something you want to learn, there's probably like 10 hours of video that we've done on iLogic. So just look that up on YouTube. From KETIV, we have a ton of stuff. But I think a really, really unique workflow, something we showed today that I know that you've gotten some calls for before as to how to even automate that kind of stuff. Do you generate separate setups, so on and so forth? Obviously, you can generate separate setups. But once you start automating 7 or in the dozens of different configurations, or there's numerous factors that change your model, that change the things like loops and the number of faces, or they get rid of complete features, right? You're going to want to start using some of the stuff that Alex showed today. So again, I'd like to thank you, Alex.
Thanks for having me, guys.
For being here today. In addition, I would like to remind you that you have an update recommended from your Autodesk desktop application. Please download those new products and features. That's cool because it's telling you probably got 2020 available. So if you see that,
looking forward to that
customers, don't be afraid. It might just be the next version of the product. So I'd like to thank everybody for showing up today. We'll see you again next week at 10 o'clock going over what's new in Inventor 2020 from our friends at Autodesk. So again, thanks. We will see you next time.